Greetings to everyone. It's quite a while now since we had this type of session for our Math Olympiad problem solving series. And since then, a lot has already happened in my life. And still today, there's still a lot of happenings. But this is now our third session for our Math Olympiad problem solving series. And in this session, we're going to tackle a problem from the 11th Philippine Mathematical Olympiad national qualifying stage. And for this particular session, the problem that we're going to tackle is particular to the field of Euclidean geometry and algebra. So once again, I'm Earl from Regional Science High School for Region 9 Philippines, as grade 11 senior high school student of Accountancy, Business and Management, or of the ABM strand. And let's take a look at our problem for this session. So this problem is problem number 24 of the national qualifying exam of the 11th Philippine Mathematical Olympiad back in 2008. So the problem goes like this. Each side of the square ABCD is 12 meters long. The side AB or segment AB is divided into three equal segments, namely segments AE, EF, and FB. Segments CE and DF, on the other hand, intersect at point H. So there exists a point H in their intersection, and find the area of triangle HCD. So by just simply looking at this problem, it's hard to imagine as to how this figure looks like. Though there are people who can just picture this out mentally in their mind. But for the sake of convenience of everyone, let's draw a figure, and our figure should look like this. We have here a figure. Okay, so we can see that in our figure, we have triangle. Square A, B, C, and D. Okay, so the side AB, this one, is divided into three equal parts or three equal segments. So we have here E and F, so that you will have AE, EF, and FB. Also, the problem tells us that there exists segments C and E here, and D and F here, for which the intersection is called point H. So we are asked to find the area of this portion, this triangle. So H, C, and D. So since we already have our figure, we can now uh, find a strategy as to how we are going to find the area of this given triangle. So recall that the uh, area of a triangle, it's simply base times height divided by 2. So I guess you've learned that in your elementary mathematics. And for this case, we'll uh, put CD as our base of the triangle. And we have to find the height of this triangle. So we can find the height if we can determine uh, which eh, what is the uh, y coordinate of this particular point, or the x coordinate of this particular point H. So we already know that uh, it's collinear with 6, so we can put it as its coordinate as 6. And let's have the step-by-step solution. So first, we must by the way, we must establish first as to why we can say that this is collinear with 6. So recall that diagonals of quadrilaterals, in which case, in this particular case, it's square, their diagonals are always equal. So it simply means that if their diagonals are equal, then there must exist a point of their intersection right exactly in the middle of the quadrilateral that if we are to draw a line there, it divides the quadrilateral into two congruent parts. So let's proceed to our algebraic solution for this. So the first action that we're going to take is determine the slope of segment BC. Determine the slope of segment EB, this one, and divide it by uh, the measurement of segment BC. So we're talking of this portion and this portion. So we are to divide this one by this one. So that gives us 6 meters and 12 meters. So by substituting this given to this one, we will have m, or the slope as we denote it in mathematics. Recall that m is equals to the slope. So it's 6 meters divided by 12 meters. And further simplifying, we will get a slope of 1/2. So meaning the slope of this line, this line segment, is 1/2. Okay, so but we are after of this particular coordinate, which we denote x, right? So, but we are not after of this, the height of that, because we're just interested in finding. Okay, we are not interested of this portion. We're just interested in this particular spot, the coordinate x. Because if we are to find this, it is already, if we are to find this, it is already telling us the y coordinate, which is 6. But rather, for clear illustration, we are to find this part, okay, this one. Okay, so we know that it must be greater than 2 because it lies beyond 2. So we know that x, no, is greater than 2. So let's proceed with the solution. So the second action that we're going to take is determine the corresponding pair of 6 in AB. So this one, okay, the corresponding pair of 6 in AB in AD. So this one, so we can write it as x and 6. So where 6 is our y coordinate. And next, we can find it by simply multiplying 1/2 by 6. Okay, how is that? Because if we are to draw a line, a segment here, okay, this exactly divides uh, this figure into two new parts. Okay, and we can get this because we know that slope is rise over run. So this one, this part, okay, let me use another ink. So this one, this is the run, and this is the rise. So we have to find the rise, okay? So that's why we are multiplying this. And we will have uh, x is equals to 3, okay? X is equals to 3. Now, the next step that we are going to take is uh, find the height of HCD. So we can do that by simply subtracting x from 12. Okay, so recall that this one, right, we have an x somewhere here. It is located here, and the height is equals to this portion. Okay, So we can have it as this 12, which is the measure of this entire side of the square. So to find this, since we already know this part, no, 0 from x, which is signified by x, we already know this. We just have to subtract. So that gives us height of our triangle is equals to 12 minus 3, which is 9. Now we already have the base, this one, which is 12 because this is a square, and this one, which is our height. Okay, so action 4, find now the area of HCD through the formula base times height divided by 2. So 9, okay, 9 meters. 9 meters times 12 meters. This one, our base, and this is our height divided by 2. So evaluating that, we will have 108 meters, okay, divided by 2. That gives us a total area of 54 meter squared because we're talking of area. So this is now our final answer. Okay, this is now our final answer, 54 meters squared. So meaning the area of this triangle that we're asked to find is this one. So that's it. I hope you have absorbed or learned some solving techniques for the Philippine Mathematical Olympiad, though this is just relatively easier compared to other problems. So I'm Earl, and have a mathematical day.